today's goal of this lecture. Today, I will see some example about bilinear form, quadratic form, what is the bilinear form, what is the quadratic form, when a quadratic form positive, definite, semi-definite, indefinite, this topic. Just as a review, in my previous video I had discussed this topic elaborately. Today I will discuss this topic just as a review. I have given the link of this topic which I had discussed my previous video. This link I have given in my description box. At first I will highly recommend you, if you don't see my previous video, at first see my previous video. Then today's video would be more clear to understand. First question, which had come CSR net December 2017 exam. Here given the matrix A and 5-year function from R2 cross R2 to R. Be a bilinear transformation, and bilinear transformation is denoted as phi v w equal to v transpose AB. Definition of bilinear form. B be a mapping from vector space cross vector space to R such that for all VW belongs to this vector space, such that beta alpha u plus beta v comma w equal to alpha beta uw plus beta buw, and beta u comma alpha u plus beta w equal to alpha times beta uv. Here this is the v plus beta times beta uv. Then this is called the bilinear form. Now notice, when a bilinear form be symmetric, the notation of bilinear form B of VW equal to V transpose AW, and a bilinear form is called quadratic form when it mapping itself, that means B of VV equal to V transpose AB. Then this bilinear form is called quadratic form. On the vector V, when bilinear form mapping itself, then this bilinear form is called quadratic form. And bilinear form means actually this is linear in both coordinate. Here given one matrix, and obviously bilinear form is denoted as V transpose AW. Here the question about, is this bilinear form is symmetric? A bilinear form is symmetric when it is positive definite. Then a bilinear form is a symmetric. Bilinear form is symmetric when the matrix A is positive definite. And we all of us know positive definite means all eigenvalues are positive, and all either all eigenvalue are positive or all principal minor are positive. Here given A is this. Here the principal minor, at first let's see the diagonal, 1, 3 is greater than 0, then determinant 3 minus 8 minus 5 which is less than 0. That means the matrix A is not positive definite. So since this matrix is not positive definite, so phi of VW not equal to phi of WV. This bilinear form is not symmetric. So option 1 is not right. Next option, there exists a non-zero vector V belongs to R2 such that phi of V comma W equal to 0, and this is true for all W belongs to R2. Is it true? Phi of V comma W. This equal to 0 means inner product AW with V equal to 0. That imply V transpose AW equal to 0. And this is equal to 0 when A is symmetric matrix. Okay? But I have seen few minutes ago, this matrix A is not symmetric matrix. So option 2 also wrong option. At first see the option 4. Option 4 indicate the map psi from R4 to R, who is defined as psi of V1 V2 W1 W2 equal to phi of V1 V2 W1 W2, and this is linear. Is this linear? At first think own self. Here phi of, we have to prove phi is linear. That means phi of alpha V comma alpha W equal to alpha times phi of VW, and this is equal to alpha times, and phi of VW means V transpose AW. Okay, and this is equal to we can write this as alpha V transpose A alpha W, and this is equal to alpha square V transpose AW. That means this is equal to alpha square phi of VW. So this is not B, is not linear. Okay. So option 4 is a wrong option. Option 3 imply there exists 2 cross 2 symmetric matrix B such that phi of UV equal to V transpose BW. Is it true option? Always by this bilinear transformation, always I will get one B which is symmetric matrix. And this B would be equal to such type, here diagonal 1 3 and here 4 plus 2 over 2 equal to 3. That means this is 3 B would be such type. I hope my all viewers have understood this is clearly. Okay, that means option 3 is a right. Next question, which had come session net 2016 exam. The question is AB n cross n matrix, then pick out the correct statement. Option 1, A has at least one real eigenvalue. Option 2, for all non-zero vector VW belongs to Rn, AW transpose AV greater than 0. Option 3, eigenvalue of A transpose A is non-zero, non-negative real number. And option 4, I plus A transpose A is invertible. For this, consider A equal to 0 0 minus 1 0. Minus 1 1. Here the characteristic polynomial would be lambda square plus 1 equal to 0, whose eigenvalue is plus minus I. So if consider n equal to 2, then A has at least one eigenvalue for all arbitrary A. This is not always true. Option 2, for all non-zero vector VW belongs to Rn, AW transpose AV greater than 0. Is it true option? Consider A equal to identity matrix. If we consider A equal to identity matrix, then it would be W transpose V, and consider W equal to 1 1 and V equal to 1 minus 2. Then W transpose V would be 1 1 1 minus 2, and this value would be 1 minus 2. This is equal to minus 1, which is less than 0. Therefore, for this W and V, I have got this is not always greater than 0, this is less than 0. So option 2 also wrong option. Option 3, eigenvalue of A transpose is non-negative real number. We all of us know eigenvalue of A transpose A is always positive. In my previous video, I had discussed this topic elaborately, so option 3 is the right option. And since always this is strictly positive, the matrix, if you consider B equal to A transpose A, this is positive definite matrix. So obviously, since this is positive definite, so option 4 also right option. So only option 3 and option 4 is the right. Next question, which also depends on bilinear form. This question had come session date 2025 June exam. The question is, let BVW be a non-degenerate. Non-degenerate means determinant of the matrix is not equal to 0. Be a symmetric bilinear form on R2, and QV equal to BVW be a corresponding quadratic form. Suppose that there exists VW belongs to R2 such that BVV equal to 0 and BVW is not equal to 0. Here given bilinear from itself is equal to 0 for non-zero vector and BVW is not equal to 0. Then which of the following option are necessarily to option 1 B WW equal to 0? Here given at first determinant of A is not equal to 0 and BVB equal to 0 for non-zero vector and BVW not equal to 0. And bilinear from we all of us know is denoted as V transpose AW. Okay. And here, since determinant is not equal to 0, that means here since determinant means product of the eigenvalue, that means lambda 1 lambda 2 is not equal to 0. That means we all of us know when bilinear from itself means V transpose A V, then this bilinear form is represented as quadratic form. And this bilinear form is not positive definite, because if positive definite, then obviously this condition would be satisfied, determinant of A not equal to 0, but it break this condition. For non-zero vector BVV equal to 0, this is not satisfied if the bilinear form be positive definite. Similarly, for negative definite, this is not, because negative definite means lambda 1 lambda 2 are negative, but for non-zero vector this would be not satisfy. For positive semi-definite this is satisfy. Obviously this would be satisfy, but here also given this bilinear form is non-degenerate. That means eigenvalue are not equal to 0. If eigenvalue is equal to 0 then this would be restricted. So positive semi-definite, also negative semi-definite, this is not be satisfied. That means only condition which would be satisfied, this is for indefinite matrix, indefinite bilinear form. And we all of us know standard form of indefinite form is, bilinear form is look like b of x1 x2 y1 y2, this is equal to x1 x2 minus y1 y2. This is the standard indefinite bilinear form. And if you consider v equal to 1 1 and w equal to 1 0, then here would be for this b of vw equal to 1 times 1 minus 1 times 0, this would be 0. b of vw equal to 1, so this would be satisfied. b of vw not equal to 0. But if you consider w is this, then b of ww would be 1 times 1 1 and minus 0, this value also 0. So for this w we can break option 1. Next, notice the option 4. Q is equivalent to the quadratic form qxy equal to x square minus y square for all xy. Notice this is the quadratic form. Quadratic form means here if this is the vector b of xy, then this would be itself xy, and this value would be, since I have given the standard indefinite form, this value would be x square minus y square. So option 4 also right option. Option 2 and 3. Option 2 indicate there exists and alpha belongs to R such that q alpha v plus w equal to 0, and option 3 indicate there exists infinitely alpha belongs to R such that q alpha v plus w. Here v and wb, those v and w such that the bilinear form with v is equal to 0 and the bilinear form v with w is not equal to 0. This v and this w here would be used. Here q of alpha v plus w. Q of alpha v plus w equal to 0 means bilinear form with itself alpha v plus w, comma alpha v plus w equal to 0. And this means v of alpha v comma alpha v plus b of alpha v comma w plus b of w comma alpha v plus b of w comma w equal to 0. That means that imply alpha square b of v comma v plus 2 b of alpha v comma w plus b of w comma w, and b of vb equal to 0. That means this imply 2b alpha v comma w plus b of w comma w equal to 0. Okay. So since for this is the rules of the bilinear form, alpha would be pull out from this bracket, then this would be 2 alpha bvw plus bww equal to 0. That means alpha equal to minus bww over 2 b beta w. This is the value of, and since b of ww and b of vw is for fixed v and w, so this alpha would be one fixed number. So option 3 implies there exist infinitely many alpha. This is wrong option. Option 2 is the right option. There exists an alpha. I hope my all viewers have understood this type of question easily. Today I will stop here. In my next video I will discuss different type of question about linear algebra, because linear algebra, this topic is very important for higher study, also for any competitive exam. Okay, see you soon, stay safe and stay positive always, and don't forget to subscribe my channel for more videos. Thank you so much.